Hello. All right, it's happened. Squirrel is on strike. I've been in negotiations with her. Um, she is demanding treats for lessons. It's not very good. Outlook does not look good. I do have treats. I can pay her, and I have been paying her in treats, but she is demanding far more than what I think is good. I mean, she's stuck inside all day. She's gonna start packing on the pounds, and only one of us is allowed to do that, and it's not her. So I'm very concerned. Right now, she is refusing to participate in anything. It was forever to take me to, took me forever to have her participate in the photo shoot yesterday for Pajama Day. That's why my Pajama Day pictures came out so late. Um, it's bad. We are we are deep in arguments over how many treats is required for how many comments per video. It's rough, but I will do my best to meet her demands. She's quite the diva. I knew this was going to happen. I knew it. She's just such a diva. Anyway, I will report back to you. This lesson, of course, will have to be done without her. But I will try and get her back to the table, and hopefully we can work something out. For our last lesson, we were talking about patterns of numbers, and she liked the patterns of numbers. I thought she was going to be okay, but she just, anyway, focusing. So patterns of numbers, this is what your homework should look like. We've got the adding of the 0.1, like I showed you. This one was just subtracting 5 each time. We were dividing 5 over here, multiplying by 4 down here, subtracting 1, dividing by 3. All of them were fairly basic. Remember that you have 2 lines, just like our piecewise functions. You have 2 different lines in this formula. You have to tell them where to start and then what to do after you start. The 7 and 8 posed the most difficulty. I like 7 because it's just 2, but it's flipping between negative and positive. And that's because they're multiplying by a negative 1. Because 2 times negative 1 is a negative 2. But once we have a negative 2, a negative times a negative makes a positive 2. Yeah, 7 was sneaky. 8, also sneaky because it was just 3 repeated. So we start at 3 and then we do nothing to it. You can just leave it as the new one is going to be the same as the old one because A1 is the same as A2 and A5 the same as A4. All right, let's take a look at the back of the homework. On the back of the homework, we were doing the first 5 terms. So this one started at 3, and then you had to add 7 each time. This one started at 1, and you had to add 2 each time. This one started at 4, and you needed to multiply by a negative 2. Notice, once again, the sign flipping there. We've got positive 4, negative 8, positive 16, negative 32. This one over here, we started at 1/81th, and we multiplied by 3 each time, got all the way up to 1. It was very exciting. 13 and 14. 13 surprised a lot of people. We had 3, and we didn't subtract 6 each time. It was 3 is our first number, and then 6 minus 3 will get us our next number, which happens to be 3. And then 6 minus this number will get us this number. So 6 minus 3 is 3 again. So this is also a nice way. It is actually exactly like 8. Notice, you can write it this way. Actually, much easier to write it this way, but they're showing you that sometimes they can trick you and write it in a different way just to be annoying. And then there was 14 where we started with 144 and we multiplied by 0.5 each time. Let's take a look at 15 and 16. 15, we are starting our sequence like normal. So A1 is going to be 1. That means we start with 1. It also gives us A2. So it tells us our next one is going to be 2. That's where these things get a little bit weird. Sometimes they'll give you the first two things. Now, to get the next one, we have to take the ones before it and multiply. So, if I have an there, before an is an minus 1. Well, before that is going to be my an minus 2. So it's saying take these two, multiply them to get this guy. So 1 times 2, gonna be 2. Once again, now we shift over. So it's 2 times 2 to make 4. And then 2 times 4, multiply that to get 8. And that is how we come up with that sequence. That one's got issues. 16 also has several issues. So let's take a look at this one. We start with 2, and then it says A2 is 1/2. And in order to get an, we need to add the two ones before it and put it next. So 2 plus 1/2 is 2.5 or 2.5. And then 2.5 plus 1/2 is 3. And then 2.5 plus 3 is going to be 5.5. And that is how we are going to do those. As I say, they get a little bit crazy, they get a little bit creepy. There's one of these, though, that's actually my favorite. It's called the Fibonacci sequence, and we'll talk about that guy later. He's very, very special. But for right now, I want to go to our lesson. Today's lesson is all about arithmetic sequences. Now, these are very special types of sequences. So let's start with an example of this. 2, 5, 8, 11, 14, dot, dot, dot. Now, if you notice, we've seen this one before. This is very similar, in fact it is, one that we have seen before. And we could do the recursive formula on this. If we wanted to talk about the recursive formula of this, we would do exactly what we did on the homework, and we would say a sub 1 is 2, because we need to start at 2, and then a sub n, we take the guy before it, and in order to get to the next one, we have to add 3 each time, so plus 3. And that would be wonderful, and that would be great. And if I want to find a sub 4, that's really easy. A sub 4, let's just do some examples here. If I wanted to find the fourth number in the sequence, that would be 1, 2, 3, 4, that's 11. It also works if they wanted to find something that doesn't exist yet, that isn't given to us. So like A6, that would be the 6th number in the sequence. So we would go to the 5th one, add 3, and we would get 17. The problem is, what happens if I want a 20? I want to find the 20th number in this sequence, I have to keep adding 3 all the way until I get to the 20th number in this sequence. That's a lot of numbers. So we've got, what, 17 and then 20, but careful, that's not the 20th number. That's 6. This is 7th number. So we're only at A7 right there. We need to keep adding 3, 26, 29, all the way until we got to A20. That's really far away. And it doesn't stop there. Sometimes the Regents will ask for A100. Well, let me tell you, I've got better things to do than to add 3 100 times. No, no, no. We do not want to do that. That is silly. That is why very special, very smart people have come up with something called the closed formula. This closed formula will actually help us determine what A100 is without adding 3 100 times. So, the closed formula is A sub n equals A1 plus n minus 1 times d. Okay. Now, this closed formula only works for arithmetic sequences. Arithmetic means adding or subtracting. So when we had some of those that were multiplying or dividing, this formula would not work for those. You would still have to go and multiply by 5 until you got to the 20th number. You would still have to do that. Arithmetic only works for adding or subtracting. Now, let's take a look at how this formula works. The first number is, of course, going to be our an, whatever we want. The a sub 1, that's going to be our starting. N is a variable. So we don't touch that, and we don't touch this guy. This is a variable. D is the difference. So remember how we had like y equals mx plus b, and we only cared about the m and the b? X and y stayed the same? Well, we're only going to plug in the start and the difference here. So my a sub n will stay the same. A1 is over here. This is A1, that's 2, plus n minus 1 stays the same. And then the difference is what's happening each time. Each time I'm adding 3. So we're going to do a positive 3 in there. So we're going to do plus 3 inside the parentheses. Now, of course, we can't leave the formula like this. That would be silly. I know, right? So we're going to distribute that 3 because we have been taught whenever we have parentheses to distribute. So that's going to be 3n minus 3. And we're almost there. We need to combine some like terms. an equals 3n minus 1. And hey, it even looks a little like y equals mx plus b. That's exciting. Well, now what happens is we have a very specific formula that looks very much like a linear formula, like a line. And that's what's going to happen. So when I want to do examples again, and I want to say a of 4, a sub 4, that means 3 times 4 minus 1, because my n is 4. I want to go to the 4th number in the sequence. 12 minus 1 is Hey, 11. Exactly what we got before. That's exciting. Let's try a of 6, make sure it still works. A of 6 is 3 times 6 minus 1. So 3 times 6 is 18, minus 1 is 17. Look at that. Works again. Now I can do a sub 20 without having to multiply by or add 3 every single time until I get to the 20th number. I can just go 3 20s minus 1, and I would get 59. Heck, I can even do a 100 really easy. 3 times 100 minus 1 will give me 299. Done. Didn't have to do anything. This is the same as if I were to write, you know how you can write 9, or let's do 8 is 2 plus 2 plus 2 plus 2. Yes? But 8 is also just 2 times 4. That's what's happening here. We could write it in the recursive form where we have to add up all of those things. Or the easier way to do it is use the closed form where it's much more simple and it's much quicker. All right, let's try another example, make sure that we understand what's happening here. So let's do another example right here. Negative 34, negative 64, negative 94, negative 124, dot, 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 dot. Okay, now I want to do this the recursive way. And I want to do this the new closed form way. If we were doing this yesterday we would want a1 and an minus 1, and we would say, okay, our first number is going to be a1, that's negative 34, and each time from negative 34 to negative 64, we are subtracting 30. So it would be minus 30. And that would be the recursive form, and we would be done. Now, sometimes the Regents will ask for the recursive form. And sometimes they will give it to you in a recursive form, and you have to find the numbers in the recursive form. And sometimes they'll do the opposite. Sometimes they'll ask for the closed form, in which case you have to do an equals a1 plus n minus 1 times d. Now, good question. Where is this? Am I going to have to memorize this formula? Funny you should ask. In fact, if you go to your bright reference sheet right here, we have something very special. Arithmetic sequence. Arithmetic sequence means to add, and it's that closed formula right there. It will give you the closed formula. Now, this of course doesn't work for, This of course wouldn't work for multiplying or dividing if our sequences had multiplying or dividing. But this does work for any adding and subtracting sequences. So since we're subtracting here, this guy will work. And of course, you don't need the formula for the recursive, because the recursive is just where do we start, and then what do we do. The recursive formula is very straightforward. The closed formula is actually an important formula, and that is why they put it on your reference table. So A1 is negative 34, n minus 1, and D is our distance. Our distance between the numbers is negative 30. And then what we're going to do, distribute that into the parentheses. Negative 34. Negative 30 times n is going to be negative 30n. Negative 30 times negative 1 plus 30. So A sub n is going to be negative 30n, and then minus 4. And that's our formula for the closed. So sometimes they'll ask for recursive, sometimes they'll ask for closed. Sometimes they'll give you certain things. Like in one question, they said A1 equals 0, D equals negative 5. And they asked you to find the formula. Sometimes they will ask you to find the sequence. So it will very much depend on which formula they want or if they want the sequence, because there are 3 different ways of talking about this pattern. You could write out the whole list of numbers. You could write out the recursive form of the formula, or you could write the fancy closed form of the formula. There are 3 different things that they could ask. And based on what you want to do with it, sometimes they will ask for A100, in which case your best bet is the closed formula. Can you get to it via the recursive formula? Absolutely. Go ahead. I would love to watch you sit there on the Regents and subtract 30 100 times before you got the right answer. That sounds like an entertaining process for someone. So just be careful. Sometimes some formulas are better than other formulas, but they all basically mean the same thing. In this example, we know that we're starting at 0, and we know the difference is negative 5. So the distance between this guy and the next guy is subtracting 5, and then subtract 5 more, and then subtract 5 more, and we get negative 15, and it keeps going like this. The recursive form would, of course, be A equals 1. A of 1 is 0, and A sub n is A sub n minus 1, and we're just subtracting 5 from it. And then the closed formula is A sub n equals A1. Nope, I know what A1 is. A1 is 0. Silly. Plus n minus 1 times d, which is a negative 5. Distribute my negative 5, so I get 0 minus 5n plus 5, also known as a sub n equals negative 5n plus 5. So just based on these 2 pieces of information, I can form that list of numbers and actually state in a mathematical way what the pattern is. Sometimes they will just give you the closed formula. I want to do one more example where they just give you the closed formula, because this guy can be annoying. So in this example, they're going to give you A sub n equals 15n plus 10. Okay. Now, this is great if I wanted to find A100. If I wanted to find A100, I would just do 15 times 100 plus 10, and it would give me a 100. But I don't want to find a 100. They want me to find the first 5 terms. So I need to start with A1. A1 is not going to be 10. I really wish it were 10. That would make life so much easier. But it's not 10. A sub 1, we got 15 times 1, because n is 1, plus 10. So 15 plus 10, actually 25. We're starting this guy at 25. Okay? A sub 2. The second one is going to be 15 times 2 plus 10. 15 times 2 plus 10, that's 30, 40. At this point, you might notice that we're not starting at 10, but our difference is 15. Each time, I'm going to be adding 15. And you can keep going. Or you can keep saying, okay, 15 times 3 plus 10. 15 times 4 plus 10. 15 plus, times 5 plus 10. Up to you. You could plug in each individual number to figure out what is the first number in this sequence. What is the second number in this sequence? What is the third number in this sequence? Or, once you get the pattern, you can just go from there. At which point you will get 25, 40, 55, 70, and 85. All right. Your mission for tonight is to try and do those closed formulas. Now, notice I only want you to do the closed formula. You could do the recursive formula if you want. Some people like to split these problems in two and do the recursive on this side and the closed on this side for every single one of them. Go for it. If you want to do both forms each time, go for it. It's good practice. But right now, I want you to focus on just that closed form. The a sub n equals a1 plus n minus 1 times d. Make sure that d is in parentheses when you plug that sucker in. I want you to find that closed formula. That's what you do on the front. On the back, it gave you the closed formula, and just like our last question, you have to find the first 5 terms. And the last 4, it gives you the closed formula, and then it asks for a random one, like A100, or in this case, A35, because they really want to know what the 35th number in this list is. They're weirdos. What can I say? All right. So that brings this to a close. I do want to talk briefly about what we are doing this week, because some of you were a little bit confused. All right, so this is what our map looks like. On Monday, we did the recursive. Today, we did the arithmetic. Tomorrow, we're going to talk about geometric. Thursday, we are going to talk about how to tell the difference between the different lists, and we're just going to be doing a summary. There will be a short quiz to make sure that you are paying attention. So Thursday, we're just going to do a nice little wrap-up and a quiz. On Friday, we're going to talk about fractals. Why? Because they are adorable, and I love them so much. Not as much as squirrel. I really need to make up with squirrel. Okay, lab. Today the bus run should have come by and it should have given you, or sorry, yesterday the bus run should have come by and should have given you a packet. That packet is the review packet. I want you to start looking at that, and that is what our labs are going to be for the rest of the week. So today, if you want to start looking at that review packet, it says Regents Review on it. You can start looking at it. I will give you more details on what I want you to do with the Regents Review packet Wednesday, Thursday, Friday. Of course, next week is our spring break. And no, I will not be posting videos during spring break. I will, however, give you a packet because that's my life. I'm evil and I give packets. So, of course, you're going to have a packet over spring break just because that's how I roll. So you will get a packet, and it will have to deal with the Regents Review packet. I will not be giving you all of the Regents Review packet to do over break. That would just be cruel. It would be funny, but it would be cruel. So I'm not going to give you the full Regents Review packets. I'm going to tell you which sections I want you to start working on. That's going to be your lab, and it's going to be your break packet. So whatever you don't finish this week in the time that you set aside for our beautiful algebra lab, it's going to end up being for break work. Thank you very much for tuning in to this episode of Izzo trying to teach Squirrel algebra. I will do my best to get Squirrel back to the table. Her demands are just so high. You don't understand how many treats she wants. She also wants my tuna storage. I've got tuna stores, and it's for me. I like tuna salad. I'm not giving her my tuna. I'll see what I can do. Wish me luck. Have a good day.